Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use stoichiometry to find the amount of bacterial tissue that's required to process a certain amount of wastewater. So let's get into this. So the question is asking what mass of bacterial tissue, and that's the formula C5H7O2N solid, is produced in a treatment plant for every 10,000 kilograms of wastewater, which contains 3.0% ammonium ions by mass. And then they say that we can assume that 95% of the ammonium ions that are in the actual wastewater is consumed. So let's get started. So this is a stoichiometry problem. I know this because one, they're giving us a certain amount of wastewater that has a certain amount of ammonium ions in it, and they want us to convert that into the amount of bacterial tissue. So anytime they are giving you one thing and they want you to convert to a different thing, you've got to use a mole ratio to do that. That's the only way to convert between one thing and the other. There's probably another way, but the most common way is to use a mole ratio to convert from one thing to another. And so that's what we need to do. Excuse me. So in your steps for a stoichiometry problem, you got to start with the unit they give you and you got to get it to moles of the substance. Once you get it to moles of the substance, you want to use your mole ratio from your balanced equation or maybe a formula to convert from moles of one thing to moles of the different thing. And then once you get your moles of the other thing that you want, then you convert that to the units that they're asking for. So let's go ahead and do this. So they want to know the mass of bacterial tissue. So we're trying to get to this. And what do they give us? They give us a certain amount of wastewater that has a certain amount of ammonium ions. So we have ammonium ions in our equation. So we should get to moles of ammonium ions, and then we could use our mole ratio. So let's start with the amount of wastewater. So they give us 1.0 times 10 to the 4 kilograms of wastewater. I'm just going to put WW for wastewater. And I need to get this to ammonia. So what do they give me? They say that the wastewater contains 3% ammonium. So anytime they give you a percentage, that's going to be a nice conversion factor. We have to remember what a percentage is. A percentage means out of 100 per 100%. So if the percent is out of 100, they're saying that 3% of the wastewater is ammonium ions. What does that mean? That means out of 100 units of the wastewater, 3 of those units is going to be ammonium ions. And that unit, we can make anything. So since they give us kilograms, we can just go ahead and convert that to, kilograms of ammonium. So since it's 3%, that means out of 100 kilograms of wastewater, we'll put 100 kilograms of wastewater on the bottom. Out of 100 kilograms of wastewater, 3 kilograms is going to be the ammonium ions. So 3.0 kilograms is going to be NH4 plus. So kilograms of wastewater cancels out. Now I have kilograms of ammonium ions. And so then what are we told? We're told that the bacteria is going to consume 95% of it. So out of this is the total amount, TOT for total. This is the total amount that's in the wastewater. But the bacteria is only going to consume 95% of it. So we're just going to use our conversion of 95%. What does that mean? This means out of 100 kilograms of NH4 plus, only 95 kilograms is going to be consumed. So we can write that as a conversion. So on the bottom, we'll have 100 kilograms of NH4 plus total. And then out of that 100, we'll have 95 kilograms of NH4 plus consumed. So then the kilograms total cancels out. And so now we have 95, we have kilograms of NH4 consumed. Now we want to convert that to moles. We have kilograms. In order to convert from mass to moles, we need to use the molar mass. And so we need the mass in grams. So because molar mass is grams per mole. So in order to use molar mass, we need our unit of mass in grams. So we're going to convert this to grams. So 1 kilogram of the NH4 plus that's consumed is on the bottom. And that's going to be equal to 1,000 or 10 to the 3 grams of NH4 plus consumed. So kilograms of NH4 consumed cancels out. Now I have grams. Now I can use the molar mass of NH4 plus. And when I look that up, excuse me, it's going to be 18.039. So 18.039 grams of the NH4 plus consumed on the bottom, and 1 mole of the NH4 plus consumed on the top. So the grams are going to cancel out. Now I have moles of the NH4 plus that's consumed. Now I can use the molar mass, now I can use the mole ratio in my balanced equation to convert the ions, moles of the ammonium ions, to moles of the bacterial tissue, the C5H7O2N. So I know that there's 55 moles of ammonium ions are consumed to produce 1 mole of the C5H7O2N product. So now I'm going to continue. So I'm going to use the mole ratio here. So I have 1 mole of the ammonium consumed on top. I'm going to put 55 moles on the bottom, 55 moles of NH4 plus consumed. And then on the top is going to be 1 mole of the C5H7O2N. So moles of NH4 plus cancel out. Now I have moles of the bacterial tissue, but they're asking for the mass. So we're going to continue and we're going to convert this to kilograms. Since we started with kilograms, we're probably going to need kilograms. So we're going to convert this to kilograms. So I need the molar mass of this substance. When I do that, I'm going to have 113.116. So 113.116 grams of the C5H7O2N. And on the bottom, 1 mole of the C5H7O2N. So the moles cancel out. Now I have grams. And then last, I want to convert that to kilograms. So I have grams on top. I'm going to put grams on the bottom here. So 1,000 grams of the C5H7O2N on the bottom, and 1 kilogram of the C5H7O2N on top. Grams cancels out. Now I have kilograms. That's what I want. So now all I need to do is multiply across the top of all of this stuff on top, divide by everything on the bottom, and I get my answer. And when I do that, I get 32.49. 32.49 kilograms of the C5H7O2N. Now I have to think about significant figures. So when you're thinking about significant figures, remember when you're the rule is when you're multiplying and dividing, your answer should have the same number of significant figures as the least number of sig figs in the measurements you are multiplying and dividing, ignoring, of course, the exact measurements or exact relationships. So here we have two sig figs here. We have 2 sig figs here. We have 2 sig figs here. Here, this is exact. We have 5 here. We have 2, or actually, this is exact. Here we have 6 sig figs. This is exact. So the least number is 2. So that means I need to round this to 2 sig figs. So I have 1, 2, cut it off after the 2. And then since this is a 4, I don't round the 2. So the final answer is 32 kilograms of the C5H7O2N. And so that, ladies and gentlemen, is how you use stoichiometry to find an answer. So I hope this video was helpful. If you enjoyed this video, if this helped you in any way, then please, by all means, like the video, share the video, hit that like button over here somewhere. Also, help me out. Subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, put that down below. If you have a topic you want me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.